In this video tutorial, we're going to show how ADAPT handles skip loading in two-way slabs. And we're going to go ahead and start by importing a Revit file. We're going to take this model here and we're going to use the ADAPT Revit link, and we'll export this file out, and this will be converted as a IMP file. We'll go ahead and save that. Okay, we'll minimize. We're going to be using ADAPT Builder 2019. We want to make sure that we have the right selections made in the splash screen. We're going to be using ADAPT Floor Pro, and we'll go ahead and say OK. We're going to import the file from File Import IMP. So this allows exchange between third-party software, Revit, ETABS, Tekla, Structural Designer, and also just internal files that are native to the Builder platform. We'll go ahead and navigate to that location. And we're going to import the entire model. So we'll just select Create New Model. There are no loads or load combinations at this point. So we have our model. This opens in multi-level mode. If we rotate this to a 3D view like so, we can see that's multi-level. We're going to go up to one of the upper levels, so I'll just navigate here. Let's go to the roof level, for example. Go to single level mode, and now we're working entirely in this particular level. Now we're going to go ahead and add some loading, so I'll just select the slab. I'll go over to loading. The two default load cases are dead and live load. We'll be using those two load cases here, specifically live load. And we're going to map load using the patch load wizard for live load to this slab. So we're now going to go ahead and create subregions using dividing lines in the slab. And these subregions are those regions that can then be selected for inclusion in a load pattern. So we're going to be using the loading ribbon under patterns. We're going to select the option for subregions. And this entry of regions can be done a few different ways. We can create closed polygons to generate the region. So we would create multiple closed regions that represent each specific area that can be assigned as part of a pattern, or we can use polylines that allow us to then if we use polylines, the program will then break those into these regions. So we're going to use the option for polylines, and I'm going to go ahead and I'm going to use kind of the frame lines to associate these polylines to. So I'll select, for example, something like this. You could put these in orthogonally also. There's no requirement to do what I'm doing here. So we'll just have 5 regions here, or 4 regions here, 4 strips rather. And then in the other direction, I'm going to add these lines. If we want these orthogonal, we can actually use the snap orthogonal mode, like so. And so we have our subregions. Now, if we go to load patterns, you can see the subregions are indicated by a little circular handle. They can be selected, and if we go and double click on this, that'll open the properties for the subregion. So in the load patterning input, the user then develops load patterns based on the presence of the subregions. We can define which load case we want to use for the load skipping. Only one load case can be defined in this input. We can also reduce that load per load reduction equations from IBC or the design code that you've selected. In this case, it's ACI/IBC. And we also have the ability to enter a skip factor. This may be required by code depending on the ratio of the live load and dead load. So we'll go ahead and select the first pattern. I'm just going to Windows select these subregions. The first pattern will be everything. However, it'll be reduced live load. So this is in comparison to just having 50 PSF over the full slab and assigning that live load case in a combination. If we use pattern 1, this will actually be using the reduced live load versus the full live load. So we'll add this pattern. There's pattern 1. Pattern 2, we're going to say something like this. Pattern 3. Press Control, select that. There's pattern 3, pattern 4. pattern 5, and then pattern 6 will do somewhat of a checkerboard pattern here. Something like this. Okay, we'll do one more. Okay, so we have patterns 1, 2, and we'll work down towards pattern 7. Where the subregion is hatched, that's indicative of live load applied to that particular region. So we can go ahead and close that. We'll say OK. And you can see under load combinations, those patterns are actually added to this dialog. So we have patterns 1 through 7. We also have the envelope of patterns skip max and skip min. So this is very important to understand the difference between using these particular entries or patterns 1 through 7. And I'll define when you want to use those two different types of patterns. One thing to note is the skip and the pattern loading was built in a legacy format for individual slabs, so for single level slabs. Now if you have multiple level slabs, if I, for example, wanted to add patterns to this level, level 6, I could create subregions or copy subregions down and create additional load patterns at a separate level. So let me go back to a multi-level view, and I'm going to mark this up. So at the roof level, we have 7 load patterns. Okay, let's assume we wanted to add another 7 load patterns here. So this would be load patterns 8 through 14, 8 through 14, and maybe we want another 7 at level 5, and we want 7 load patterns there. These will actually be load patterns, 15, let's say, through 20, 21. Okay, so we have a total of 21 load patterns that would be defined in this model. Okay, so the load patterns have to be differentiated between levels. We cannot use load patterns 1 through 7 at levels roof, 6, and 5. They have to be separate groups of patterns. Once we add these patterns, those would also be added up here in the load combination list. So rather than having 1 through 7, we would actually have 1 all the way over through 21. If we were running this model globally and we wanted to include the loads for each pattern, we would actually need to write, maybe we would have one combination service total, for example. And that service total pattern, we want to determine the stresses based on a global solution, a multi-level solution. We want to determine the stresses for the design strips at each one of these levels based on a multi-level solution. So what would need to happen is we would have to write service total combinations 1 all the way down through 21, and this would repeat for each unique combination. Maybe we have 3 combinations. We have service sustained and maybe initial. This is relevant to a post-tensioned design, for example. And so we would have this replicated 3 times. So 21 times 3, we would have a total of 63 combinations just to take care of all the load patterning happening for these 3 levels. If your intent is to just run level 6, for example, in single level mode, then we would just select the combinations that reference those patterns. So patterns 8 through 14, we would have a group of 7 in each one of these. We would have to run a total of 21 combinations individually at any one of these floors in single level mode. Let's go back to our example. We're going to go back to the roof. So here we're just looking at this in single level mode. We're not looking at it globally. I just wanted to bring that up because that is something that can be done in the software. So here we're looking at a single level, and when we analyze the structure, we have really 2 different levels of results. We have just the pure or raw analytical result, and those might be results like deflection. I want to know what the deflections are for the slab undergoing all of these patterns. So any analytical result that's in a contour form, or a frame element or shell element, anything derived from those 2 element types in terms of results, those can utilize the skip max and skip min for the patterns. So if I wanted to evaluate deflection, for example, for all of my patterns, I might include, instead of including live load, I might go back, actually let me leave that there and I'll clone this combination. So let's clone this. I'm going to clone that one and I'm going to call this, we'll call it total max, and I'll call this total min. Okay, and we're going to set this to, this should be max here, so we'll set that to 1 and this to 1. I'm actually going to remove the live load here. This is the load case that we defined as being skipped. So we're going to just take our envelope of the live load that's being skipped, and I want to evaluate the deflection in the slab, just the linear elastic response based on these two cases. This here would just include live load everywhere. Now, so for contour results, for deflections, for example, this is how we can set this up. For design strips, if we wanted to design the strips, evaluate stresses on the strips, evaluate reinforcement on the strips, and so on, we have to use load patterns. And that is because of the way we process the strips in the nodal integration process. It goes back and it utilizes the nodal results in each node when it integrates and designs the section. So that's part of that process. And what can happen is if you assign skip max and skip min, and I use these combinations that include those two envelope solutions to evaluate stresses, evaluate actions, evaluate reinforcement on strips, anything pertaining to strips, you essentially could have a situation where the integrated line could include nodal actions and combine them based on different solutions for different patterns. So we want to make sure when we evaluate design strips, we have to actually write a separate combination for each pattern. So this would look something like this. If I wanted to evaluate service total for stress on design strips, then what I would need to do, I'm going to go ahead and clone this again. Okay, we're going to clone this. Let's clone this 7 times. Okay, there's my 7 clones, and we're going to go ahead and delete out these factors here, and then I'm going to add the pattern. So we're actually starting backwards here. Pattern 1, 6, 5, 4, 3, 2, 1, and those are the patterns we want to evaluate for strip results. Now it may not make sense to actually set up both entries. In other words, if we already have to include these patterns for example, for deflection, we may not have to include these. The only reason you would want to include these is because if you look at contour deflections, you would actually have to go through and look at each individual result based on the pattern, whereas if you use the skip max min, you only have to see that once or twice for minimum and maximum. So in other words, we don't overlap and envelope the contour results graphically. So this is how we would set up the model for the purpose of evaluating contour results. It's not only deflections, it could be moment XX, moment YY, in-plane axial forces or stresses, and so on. Now one more thought with this, if you need to evaluate strength level combinations for the patterns, we need to know what are our demand moments at these strength level combinations and what is the ultimate reinforcement for each pattern. Then again, you would replicate this type of input multiple times. So there would be 7 inputs in this case for each unique combination. So there'd be 7 here, 7 here, there'd be a total of 14 for strength, another 7 for service, and another 7 for initial. Once you've done that, we can go ahead and analyze the slab. I'm going to go ahead and go back to my default display. I'm going to set up some design strips here so we can look at that process for evaluating the patterned combinations. I'll use the dynamic editor, and we're going to use the X direction first. So we're going to assume this is just an RC slab. We'll just add some strips here. We might want to add a few middle strips, so we'll add a strip right through here. Okay, and then I'll switch this over to the Y direction. And here, if I bend this line, I could actually create a continuous line there. I'm going to go up to this wall, something like that. I'll assume that's just a middle strip. I'll say that this is, there's a middle strip, and then just a middle strip there. Column strip on the outside. So something quick like that to generate the strips. I can go ahead and generate those. This cut is occurring outside of the slab, so if we add a Y direction splitter here, let's see if that cuts that off. Okay, so that just bounds that tributary to that line. We're going to go ahead and mesh the slab. We'll execute, and you'll notice these patterns are actually stored here. This is done automatically so that we solve the patterns and we can superimpose them into the load combinations. So we want to make sure we solve these patterns with the combinations. Okay, and then we'll go ahead and design the sections. Okay, so when we talk about a contour result or a general analysis result, we're mainly talking about things like slab deformation, slab actions. These are all based on contours, stress maps, contour maps here. Even for frame elements, we will be talking about things like column actions, for example, or beam actions or wall actions. So anything that's a component-based result versus a design section result can utilize the max and min combinations. If we go, for example, to the skip max and min, let's go ahead and collapse that. I'll collapse this also. We're going to go to the service combination here. We have this one called total max, and if we go ahead and produce the deflection result for total max, this just indicates an envelope of all patterns based on that maximum value, maximum meaning maximum vertical deflection downward. And then if we go back to, this is for example 0.81, if we go back to loads and I select min, then we have minimum is negative 1.03. So on the negative side, minimum would actually be the greatest negative value. Maximum will be the least negative value, or once it encroaches into positive or upward deflection, it would be reported as the positive deflection. So this skip max and min allows us to look at contour results based on those two entries in the load combination dialog that we set up. Once we generate strip results, then things change. So we'll go ahead and turn off the contours there. Notice also very quickly, if we look at a frame diagram, for example, a column axial force diagram, we have our minimum axial force and then maximum axial force. So this allows us to also envelope based on the patterns max and min for any frame element based result, columns, beams, and so on. We'll go ahead and turn off those, and we're going to go down here to design sections. So when we're looking at design section results, I'll use the floor design ribbon. I'll turn on the X direction, and maybe we're looking at actions. So if we were to go back to the load combination list, and let's say we use total max, we still could get a solution for this. If I look at, for example, the bending moments on these strips, the bending moments will be produced for for the result that we've selected. So this includes live load, skip max versus skip min. And if I toggle that, those values will change. But the difference here is if we compare these max and min values and we go through and individually check service 1 through 7 for the bending action, you may see a miscorrelation between a value at a specific section because of what I explained earlier in how the program integrates over the nodes when we run the design of the sections. So for any strip result, it's imperative to use not the max min but the individual pattern results. And we could actually envelope those if they don't include these total max and min. So one thing you may want to do is actually segregate those inputs. If I come back to load combinations and I just say I want to set this to no code check, this no longer is a service combination, so it's no longer enveloped with service combinations. Once I do that, I could reanalyze. And then we're going to go ahead and redesign the sections here. Okay, and now you can see the service the service selection pull down here contains those patterns individually, plus the two that included both full live load here, service sustain and total. These are the two default combinations. But if I'm looking at actions, for example, again, maybe bending along these strips, I can always now include the envelope of those actions. So I can envelope the service and I get values for max min based on the individual pattern. So this is just another way to just envelope the patterns once we break them out individually into combinations. Ultimately, you could do the same for things like stresses and so on. If we have post-tensioning, we don't have it in this model, but we could envelope stresses, pre-compression, and so on for these patterned load cases. If you have any questions about how to set up load patterns and skip regions, please contact us at support@adaptsoft.com. Thank you.